Welcome to Season 3, Episode 1 of OnDecompile. My name is Antoine, as always, and tonight I am solo in the studio. We are going to take a little look about the different types of rendering. The reason why I want to do this episode is because lately I've been discussing with a lot of people about rendering, about what it is and what is actually what is our job, what do actually rendering programmer does, what's the difference between if you work into like a game studio, what kind of rendering type you do versus if you work in a movie studio, and yeah, just a bit to demystify what are the different types of rendering. It's gonna be a kind of overview. I won't dive into every little details because I think it would make a very endless show, and we could definitely have some people coming to the mic talking and explaining more the algorithms than I can do. But I just want to make a little overview because I guess everyone, it's a show on rendering. I'm very passionate. It's weird. I'm every day I work, I wake up, I open the machine, I start to code. But during Christmas time, by the way, Happy New Year, Happy 2021. I hope we will have a bit less COVID freak year. Anyways, we won't go into this because it's not a mandate of the show. But yeah, I usually don't talk about this on the podcast. Yep. So during Christmas time this year, I was talking a lot with my mom and stuff, and she kind of understood the concept of rendering. She's like, okay, I get it. Computers are machines. Machines run software, the hardware. I won't go into all the hardware and software stuff, but I just explained what is my job, and I was very, very I had a 2-minute break. I was like, okay, what's explain rendering in few sentences. If you are a programmer, what is your job as a programmer? Well, to write program, right? So you write code. We are programmer too, but it's it seems so weird and so strange to explain what is rendering into a few lines. I was like, okay, let's kick off season 3 with an episode talking about rendering. What's the type of rendering? Why are they used for? Why are they so powerful? What's the pros and cons of different families of rendering? And also to kind of make an overview to wrap our heads about the different families of rendering and stuff. I know a lot of graphics programmers listen to the show, so I'm sorry if I hit your intelligence or if you feel this episode is it's more like a gentle overview, chilling around, shaders, we won't go into hardcore stuff. It's good sometimes to take a few moments in the studio, sit down, explore a little bit. And I just bought myself a new microphone, and I feel like my voice is sounding FM. I'm kind of happy. Anyways, it's the New Year show. It's the season 3. We kick it off. Thanks to everyone who listened. Thanks to everyone who took the time to like the page, share. I have to be honest with you, I'm so bad with social media for promoting the podcast. I know there's a Facebook page. There's been people liking the Facebook page, and I went to the page and it's oh God, the last time I posted was in April, and now we're in January 2021. So that's the promise. I'll try to make it more on Facebook, but yes, sorry if I'm not that good with promotion. Just, you know what, subscribe to the show, to the RSS feed, and probably just go on the website or, go on Twitter. Everything's happening on Twitter in real time. So, welcome. Thanks a lot. I hope you had a good time. I hope you're staying safe, sane and safe. I guess, we're now at this point where it's we try to stay sane. We're back in lockdown here, and a lot of time solo in the studio. So, it's the new season. I hope you like it, and I hope to have more guests coming up. There's some good episodes coming in the next few weeks. I could probably say we will receive. We will receive Jacques Green, which is a like electronic music composer. Also, Derek Ray from McGill University, which he works a lot on like graphics programming. Then we have Peter Shirley, who will be back in the studio with Olivier. Olivier is like the co-host. You heard him on few shows. So yeah, there's gonna be a lot of good things for this new season. But anyways, tonight we talk about rendering, different types of rendering. What is the difference between rasterization and ray tracing? What is offline versus real time? What is actually rendering? Let's have some fun. Welcome to OnDecompile Season 3, Episode 1. So I guess the first thing we need to define is what is rendering. Like renderer, rendering, graphic programming, 3D programming. Oh my, there's so many terms out there. Let's just break down to this very single thing about rendering is actually the process of writing a software that outputs an image. Some softwares, they output your tax incomes, and some others, like renderer, they output some image. Okay, now that this is stated, we use the machine to write software. The software use the hardwares, and grinding a lot of mathematical equations, they produce a beautiful image. That's it. Now, what does it actually means? What those different types of algorithms? How are they composed? What they use? What's the idea behind them? What's the pros and cons? Rendering is like, it's an umbrella. And under these umbrella, there's like, you have real-time versus offline rendering, which I think we will discuss first. So what's the difference between offline and real-time rendering? Well, real-time means it's real-time. So, example, if tomorrow morning you watch a Pixar movie or whatever movie that has some special effects or 3D into it, and you scream to your TV, move left, open the door, go back. Like, there's no way that the movie is gonna change based on your input. This is an image. Like, I mean, don't scream at your TV. Well, if you do, maybe, I don't know, if you take some substances, you might see, I won't go there. Anyways, you cannot scream at your TV and go like, go left, or go right. Like, it doesn't really care about the input. While real-time rendering is like video games. You know, video games, you have a controller in your hand, you could move around the joysticks, and you see the imagery generated by the renderer, by the algorithms, creating a beautiful image, like 60 times or 150 times per second or 30 times. It depends on a lot of things, but yeah, this is what we call real-time. Real-time rendering is a family of algorithm that needs that have one big constraint, which is time. Like, you cannot go, you cannot say, okay, here's your video game. It's like the most beautifully rendered video games, but it runs at 1 frames per minute. Have some fun, play with it. Like, you won't sell any copy, because like the goal of real-time rendering is to generate image or renders or generating image in real time. So 60 times per second, your computer needs to create a new image that will give the illusions to the user of the software or the game, whatever, that it's real time, it's reactive. You know, if you move around your joystick, the character is going to run, it's going to sit down, it's going to open a door, whatever. If you turn off the lights, then the whole scene is going to become black. If you open the light, it's going to be brighter. All of these are real time. We associate a lot real time with video games, but imagine, like, during Christmas time, I went to the dentist, and like they scan my mouth. I don't know what they use, but like in real time, the dentist was kind of looping around like a 3D model of teeth and my mouth. I was like, oh, this is done in real time. You know, like the dentist She wants to kind of in real time twist around, rotate around the mouth, and kind of have a real time kind of feedback from the software. So it's used in bunch of things like real time simulation to like anything that is 3D generated imagery that needs to run and to give the impression to the user that it's real time is real time rendering. It uses a whole bunch of families of algorithms. And it uses the GPU to generate like image in real time. More and more, we tend to see a kind of like merging point where we have both incredibly well produced and beautiful renders while it runs in real time, especially with the real time ray tracing stuff that we had the chance to discuss with Peter Shirley. Go to download the episode if you want to get deeper into it. But yeah, real time rendering. You use the GPU a lot because it kind of rasterized the image. We're going to go into rasterization a bit later. But the other big family is offline rendering. And offline rendering is like the most, it's I would say it's the most opposite. It's not that much opposite, but as in real time, you have one constraint, which is time, which is like you want to generate images the faster as possible. In offline, it's much more about like you want your image to look freaking good. Like you want the image to be like, you don't care. It could take like 10 days to generate one frame. That would be a very long time, but you get the idea. Like you just want the image, the final output to be so crisp, so beautiful that you think it's a real image. This is called offline rendering. It's used in a wide variety of industry and also software. If you watched like a movie by Pixar, it's done using offline rendering. Because like there are movie studios, the artist can work on very complex geometries, complex scene. And like what you want to do is just, you want to render them, right? Like once, like the time is not that much important. Like, of course, if you say in 2 years, you need to project the movie in cinemas and to distribute it around the planet, then like you need to take like this in consideration. But based on one frame, it could take 1 hour to generate a frame. What you want is one thing. It's freaking beautiful, physically correct lighting and all of these. Those kind of renderer, they use what we say, or they're somehow under the sub-umbrella of offline rendering. In those kind of renderer, everything like, you know, when you sweep around pages in IKEA magazines, all those beautiful crisp wood tables in your kitchen you want to buy, they're probably generated using 3D to some extent. And like all the software, Maya, 3ds Max, C4D, they use offline rendering. The reason why is because time is not that much useful in those places. Like you can allow the computer to generate and to calculate way lot more data that you would have in real time. Like to some extent, you're like, okay, I don't care. Like I could leave my machine grinding numbers for 10 days in a row. What I want is physically correct and beautiful, realistic picture. That's the word I was looking at, like realistic. It's used into wide variety of things in cinema a lot more. So I would say like the main two kind of difference, let's say that now we have the umbrella of rendering. On the left, we have like two sub umbrella. The first one is real time and the other one is real time. Real time is like video games and offline is like movies, where it's like in offline, you can allow a lot of things, like a lot of algorithms that consume a lot of times. While in real time, you want to, produce the best quality, but you have to generate them very quick because like it needs to be real time. So there's also algorithms under them. And I think that the most, like, let's start with offline rendering and then we're going to take a look like what's the difference between the two. In offline, a lot of the algorithm used is called It's based on ray tracing. Some people say ray tracing is an algorithm. It is to some extent, but it's much more like it's a technique. Like Peter Shirley stated, it's a tool, and this tool is a hammer. And I think it's very that. Like ray tracing is an algorithm that it's quite easy to understand. So you basically make somehow the inverse of how the light behaves in the real world. In real world, like your eyes, you see what you see is like, okay, there's lights bouncing around, I don't know, the tables, your computer monitor, the walls from where you are at the moment, and they get into your eyes, and your eyes with the rods and the, I always forget this word in English. Anyways, like your eyes get the info, and the brain, yeah, you have you see. Okay, I'm far from, I don't really understand what's happening in the brain at this spot, but you kind of get the idea. Like lights bounce into your eyes, and your eyes, like that's basically what allows you to see. While ray tracing is kind of the invert, you take you generate the same kind of behavior, but at the opposite. So you have the highs, which is a position in 3D space, and you shoot a bunch of rays for every pixels of the image you want to render, and using mathematics, you kind of check out where does this ray hit an object. When it hits an object, you do kind of the same thing, so you send like into the form of like a hemisphere in all direction, you send rays, and eventually like you're gonna do this recursively, and you're gonna hit the light, and then you kind of go the other way, and you kind of have the information about what's the amount of light at this point. I don't know if this is somehow clear, but it's, yeah, you kind of send ray into the world, and the ray would actually be like implicitly casted. Not implicitly, sorry, bad English. I'm kind of getting tired, but like the rays would hit object into the world you want to render, and it's extremely like it's extremely long to simulate, because like for every ray you send like rays and rays, and then you make them bounce around, and you try to snitch around the lights, and then you need to calculate like the shadows, you need to calculate the textures, everything. Damn, it's very long. Ray tracing is one of these. Like you see path tracing too. I mean, we made an episode with Peter Shirley on ray tracing. If you want to get a bit more about why is it called ray tracing and so on, go listen to ray tracing algorithm with Peter Shirley, which was extremely interesting. On another hand, there's like, there's this way. There's this, and I think we cannot talk about offline without talking about PBR, which PBR stands for physically based rendering. Matthew Farr, which now I think works at NVIDIA, proposed at the beginning of the 2000s a book called Physically Based Rendering, and it was basically a way that instead of trying to like look around ways to make the image better, it was like, okay, why not use the physicality of light and how it actually behaves in the real world to to blast around and to make our algorithms more efficient using the real world physics to create more realistic rendering. So it's kind of the big idea of offline. Like there's a bunch of things around. For sure, we could dive into like what's the difference between like what's the rendering equation, what's offline, like what is not offline but indirect lighting and stuff. But I guess it's just kind of a weird, like it's not a weird, but it's like a the most basic kind of thing, like ray tracing. And if you want to learn ray tracing, just take a look online to ray tracing in one weekend. You will have all the infos you need because Peter Shirley wrote a book on it. If you want to get into a bit deeper, you should probably take a look to physically based rendering, which explains a lot of things that makes those image and makes rendering so powerful nowadays to generate beautiful imagery. On the other hand, we have the real-time rendering. And in real-time, they use their own little places, their own little algorithms, but they use a lot the GPU. The main image is like rasterization, which is rasterization. It's like it's an algorithm once again, but it's basically creates pixels out of 3D data. So you kind of have raw pixels that you can manipulate through what we call the rendering pipeline. And the rendering pipeline basically uses the GPU to create more flexible ways to 3D programmer to program along the way. So like vertices, let's take a little quick look to how actually rasterizing work. In a very simple way, you define a vertex buffer. The vertex buffer handles all the points in 3D space from the shapes you want to draw. You send them to the GPU. The GPU handles them using the vertex shader. In the vertex shader, you could mix around, play around those, change the position and stuff. And then it sends to like the rasterizer would basically create pixels for you to shade into based on these 3D information. And once again, once you have this pixel, you use what we call the pixels or / fragment shader to play around with these pixels. So let's say you want to change the color, make it a bit more bluish, you could tweak around in the pixel shader. So rasterization is extremely fast, and it's used into pretty much all the real-time application. If you don't use rasterization into your real-time, you probably don't do real-time. And real-time is used in video games a lot. There's like it's also very, very well documented, because the reason why it's like GPUs and stuff kind of took over the world of rendering is because there's like API. So nobody nowadays open like assembly code and type stuff. Like there's company like DirectX from Microsoft and OpenGL who propose like implementations and abstractions over drivers to allow the programmer to use those API and send data to the GPU to crunch using using API, open programming, programming API that you can use in C and C++ to send the data to the GPU, and then mess around with them. So it's very nice. I love real-time. I think it's wonderful. All the things like Unreal Engine, Unity, they use like those kind of algorithms to allow users to create more awesome shapes. And the beautiful thing about real-time is that it also includes a lot of algorithms. Like there's many ways, like you could use like how do you actually shade a thing, how do you load a texture, how do you switch around types of shading to use per pixels or per vertex shading, how do you calculate, like it's a whole field you could dive for the rest of your life. But for now, let's simply imagine that rasterization is you take a vertex buffer, which is a list of 3D points, set them to the GPU. GPU would process them and creates a beautiful texture out of them, which is rasterization. So, on another hand, we discussed the two main, rasterization versus offline, real-time versus offline, and ray tracing versus rasterization. I tended to make this episode a bit like around half an hour and stuff, so this way you could have them into, I don't know, if you went to run like 5 kilometers or something, you could have some fun listening to them. I want I want to make a bit more of those episodes while exploring in the next few weeks to come for season 3, a bit more of a solo episode. So I hope you liked it, and see you into the next episode. And once again, listen on Spotify, iTunes, whatever you are wanting to listening from. And if you feel like giving me a little like on Spotify or follow, would be very appreciated. Thanks a lot, and have a very good 2021 year, everyone. Antoine here. It was OnDecompile Season 3, Episode 1. Difference between rasterization and ray tracing. It's maybe going to be called real-time versus offline rendering. Anyways, have a good night. Thanks.